Chapter 6 is about momentum and collisions. Follows Chapter 5 nicely. Chapter 5, we had the conservation of energy. Chapter 6, we're going to have the conservation of momentum. The first section introduces the idea of momentum and a new quantity called the impulse. Let's try to take a look at this. If we go all the way back to Newton's second law, we have net force equals mass times acceleration. This will be a little bit loose with the math, but it more or less conveys what's going on. The acceleration, of course, is the change in the velocity divided by the elapsed time. If we want to consider it this way, we can take the mass and bring it within the change delta symbol. In fact, we can rewrite this so that we have the change in the mass times the velocity divided by the elapsed time. And mass times velocity is momentum. The change in the momentum divided by the elapsed time. P equals the mass times the velocity, these are vector quantities, is the momentum. Mass times velocity is the key part. They needed a symbol though, kind of a shorthand. They went with P, coming from a Latin term, something along those lines. P is momentum. And this really is closer to the way that Newton himself wrote his second law. So while we often say net force equals mass times acceleration, Newton would have talked about the net force equaling the change in the momentum of the object. What we gain from this is the possibility of a mass that's changing in time. For instance, if the object we're observing is a pickup truck full of dirt, but the dirt is leaking out, as long as we're focusing on the truck and the dirt within it, the mass is constantly decreasing. We haven't up to this point had to worry about a mass that's changing. Or if we were looking at a rocket as it lifts off and is blasting out into space, the mass of the rocket containing the fuel is going to constantly decrease. Looking at Newton's second law as expressed here helps us to handle situations like that. Nevertheless, we'll actually be dealing mostly with objects that don't change their masses, and yet it still turns out that momentum is a useful quantity. We're also going to have, in fact, let's go back up. If this is the net force equals the change in the momentum divided by the elapsed time, we could take that equation, multiply both sides by the delta t, and we would have the net force times the elapsed time would equal the change in the momentum, and one or the other, it's kind of your pick. This is considered an important enough quantity. It's given its own special name, and that's the impulse. So we can think of the impulse as being the net force times the elapsed time. We can also think of impulse as being the change in the momentum. Introducing a new quantity may not seem that worthwhile, and I would really agree, except there's one additional point here. Usually an impulse force is a very large force that is exerted for only a brief period of time. For instance, colliding with the tree, driving a car, hitting a tree. Please avoid that. But that is a huge force. No matter what other forces are acting on the car at the time, the force from the tree, the impulse force, is absolutely huge compared to the others. When you have an impulse force to an approximation, the net force will equal the impulse force. So during the brief time period that the impulse force is being applied to the object, we can pretend that that is the net force. We don't have to worry about any other forces that are acting on the object to a first approximation, and that can simplify matters. It'd be very bad of me not to also at least comment on the SI unit for momentum. Since momentum is coming from mass times velocity, it's simply the kilogram times a meter per second, or if we go back up to the impulse where we have the change in the momentum, that would have the same SI unit as momentum, and we have this expression, the force times the elapsed time, that shows that momentum could also be expressed as a Newton times a second. So either one would work for momentum, and it's kind of sad. I feel sorry for momentum. Although it is an extremely important quantity, it doesn't get its own specially named SI unit. And then there will be an impulse problem or two posted out in the videos, and you can take a look at those.